Welcome back, everybody. Today's deep dive is going to be out of this world.
Literally.
Yeah, literally. We're going to be talking about AI and asteroid mining.
Very cool.
We've got this chapter from a textbook we're looking at that really gets into the nitty-gritty of how robots are using AI to mine asteroids millions of miles away.
Yeah, it's pretty wild stuff.
And you might be thinking, why should I care about robots mining asteroids way out there?
Right.
And it's a good question. But what I think is so cool about it is how this technology is actually helping us solve problems we're facing right here on Earth.
Totally.
Things like how to use resources more efficiently or finding new ways to do things that are more sustainable.
It's all connected.
It is. Plus, Cam on space exploration. Always awesome.
Always.
So we're going to cover a lot of ground today. We'll talk about how AI is helping robots navigate the vastness of space, find those valuable resources out there, and even keep those robots running smoothly in a pretty harsh environment.
Yeah, we're also going to get into some of the ethical questions that come up when we're talking about robots making decisions in space.
Right. It's a whole new frontier.
Absolutely.
Okay, so first things first. Why do we even need AI in space in the first place? Why not just control these robots remotely like we do with drones here?
Well, it seems like it should work that way, but space is a very different beast.
Mm,
The biggest hurdle is just how unbelievably vast it is.
right.
I mean, the distances are so huge that it can take minutes or even hours for a signal to travel from Earth to an asteroid and back.
Wow.
So trying to control a robot in real time with that kind of lag, forget about it. It'd be like playing a video game with the worst lag ever.
Yeah, but with much higher stakes.
Exactly.
Yeah.
And on top of that, asteroids themselves are super tricky environments. They're constantly rotating, so the sunlight's always changing.
Oh,
The
right.
robot could be drilling away, and then suddenly, boom, its solar panels are in shadow, no power, game over.
Yeah.
So these robots need to be crazy smart. Like, they need to be able to think on their feet and make decisions without waiting for instructions from Earth.
So that's where AI comes in.
Bingo.
I see. So the textbook goes into detail about how AI is tackling these challenges. The first one it talks about is navigation and mapping.
Right, so imagine a robot out there with lasers, cameras,
Hmm.
radar, the whole shebang.
Go.
It uses all that data to make a super detailed 3D map of the asteroid. Spots all the craters, boulders, anything that could be a problem.
It's basically building itself a roadmap.
Exactly. Like a self-driving car, but on a space rock.
Oh, that's a great comparison.
And what's really cool is how a lot of the AI that's being developed for self-driving cars here can also be used for robots navigating asteroids.
Oh, wow. So advancements in one field can really help the other.
For sure. It shows you how space exploration can push the boundaries of technology in ways that end up having a real impact back here on Earth.
That's awesome. Okay, so let's say our AI-powered robot has mapped out the asteroid. How does it actually find the good stuff? Like, how does it know where to start digging?
That's where resource detection comes in. One of the techniques is to analyze the light reflected from the asteroid's surface.
Okay.
So different minerals, they absorb and reflect light in their own unique way, kind of like a fingerprint.
Huh.
And AI can look at these patterns, these spectral patterns, and identify what's there. It can even estimate how much of it's there.
That's amazing.
It is. And remember that article you sent about rare earth minerals?
Uh-huh.
You know, those elements that are super important for our smartphones and electric cars?
Yeah, they're getting harder and harder to find here.
Exactly. And a lot of those are actually super abundant on asteroids.
Oh, really?
Yeah, so AI could be the key to finding them out there and solving the scarcity problem here on Earth.
That's pretty incredible. So we've got a robot navigating, it's pinpointing the good stuff. But what about keeping the robot itself running smoothly? It's not like we can just send a repair crew out there if something goes wrong.
Right. And that's another area where AI is proving to be a total game changer.
How so?
Well, think of it like giving the robot a robotic doctor, right?
Yeah.
So it's constantly monitoring things like temperature, pressure, vibration, all its vital signs, and looking for any early warning signs of a problem.
So it can predict potential breakdowns before they happen.
Exactly. That's what's called predictive maintenance.
Huh. Interesting.
And this is actually becoming super important in lots of industries back here on Earth, too, not just in space.
Oh, look how.
Well, think about manufacturing, transportation, energy. Anywhere you have machines that need to run smoothly, this kind of predictive maintenance can be a lifesaver. It helps reduce downtime and just makes things way more efficient.
That makes a lot of sense. Okay, so we've talked
Yeah.
about all the cool things AI can do in asteroid mining.
Yeah.
But what about the actual learning aspect? Like, what kind of learning are these robots actually doing?
Well, There are three main types of machine learning that are crucial for asteroid mining.
Okay, what are they?
So there's supervised learning, unsupervised learning, and reinforcement learning.
Okay, let's break those down one by one.
Sure.
Starting with supervised learning. What's that all about?
Okay, so imagine you're trying to teach a robot how to identify a specific mineral, like, let's say, platinum.
Okay.
With supervised learning, you basically show the AI tons and tons of labeled images of platinum ore,
Okay.
and the AI learns to recognize the patterns in those images that indicate, hey, that's platinum.
So it's like training a dog, but for robots.
Haha, pretty much.
And it's able to pick out those subtle features that we might not even notice.
Right. And a lot of time this uses a special type of algorithm called a neural network.
Neural network.
Yeah, those are designed to kind of mimic the way our own brains work.
Oh, wow.
They're really powerful tools for image recognition and analysis.
So it's like giving the robot a special sense that lets it see what we can't.
Exactly.
That's wild. Okay, but what about unsupervised learning? How is that different?
Okay, so with supervised learning, we're basically like spoon-feeding the AI all this labeled data.
Right.
But you mentioned unsupervised learning too.
Yeah.
So what's that about? Is that like letting the AI just figure stuff out on its own?
Pretty much. With unsupervised learning, we're not giving the AI any labels. We're just giving it a ton of data and saying, okay, find the patterns.
Oh, wow.
It's like giving it a giant jigsaw puzzle, but not telling it what the picture's supposed to look like.
So it's all about discovery then?
Yeah. It's perfect for when we're exploring an asteroid for the first time and we don't even know what you're looking for.
Oh, I see. That makes sense.
These algorithms can cluster similar areas of the asteroid together based on all sorts of things. Composition, texture, density. And that could lead to discovering totally new resources or formations we wouldn't have even thought to look for.
It's like having an AI geologist right there on the asteroid.
Exactly. That's pretty cool. Okay, what about that third type of learning you mentioned, reinforcement learning? How does that one work?
Reinforcement learning. That one's all about trial and error.
Trial and error.
Yeah, think of it like teaching a robot to ride a bike.
Okay.
It tries, it falls, it learns from its mistakes, and eventually figures out how to stay upright.
So it's less about feeding it data and more about letting it learn through experience.
Right.
But how does that apply to asteroid mining? What's the robot's bike in this scenario?
Well, think about a robot trying to move around on an asteroid. Low gravity makes things tricky.
Yeah.
It has to figure out how to move efficiently, grab samples, avoid obstacles, all while conserving energy.
Right.
So with reinforcement learning, the AI tries different things.
Yeah.
Every time it succeeds, it gets a little reward. Every time it fails, it learns what not to do.
Interesting.
And over time, it becomes a pro at navigating that environment. It gets better at making decisions and carrying out tasks.
It's constantly refining its understanding of the environment and what it can do. Wow. Okay, so we've covered navigation, resource detection, health monitoring, and these three types of learning.
We've been busy.
It seems like AI has pretty much every angle covered.
Yeah, and that's just the tip of the iceberg.
Really?
Remember we talked about how communication delays make real-time control from Earth pretty much impossible?
Uh-huh.
Well, that's where some of these other really cool tools come in, like computer vision and natural language processing.
Oh, yeah. The textbook talked about those. Those are some of my favorite parts. Let's dig into those a little more. Computer vision first. How does that work?
Computer vision is basically giving robots the ability to see and understand what's around them.
Okay.
So it involves cameras and AI algorithms that can process images and extract information from them.
So it's not just taking a picture, it's actually understanding what it's seeing.
Exactly. And in asteroid mining, computer vision can do some really amazing things.
Like what?
Well, for example, it can help with navigation. The robot can recognize landmarks, avoid obstacles, and map its surroundings, all using its eyesight.
So it's kind of like having a built-in GPS system, but instead of satellites, it uses visual cues to find its way around.
Yeah, that's a great way to put it. And that's not all. Computer vision is also super useful for analyzing the composition of the asteroid's surface.
Right, like figuring out what kind of minerals are there.
Remember we talked about AI analyzing light to identify minerals?
Yeah.
Well, computer vision can take that even further. It can analyze things like textures and shapes to classify those minerals even more accurately.
So it's really like having an AI geologist out there with the robot.
Exactly. It's like they're working side by side.
This is incredible. But we keep talking about how communication delays are a big problem in space. So if we can't just joystick these robots around in real time, how do we actually interact with them?
That's where natural language processing, or NLP, comes in.
SLP.
Yeah. NLP is basically giving robots the ability to understand and respond to human language.
So, like, we could just talk to the robots and tell them what to do.
You're getting the idea. It's not quite like having a casual conversation,
Okay.
but NLP allows us to give instructions and get feedback in a way that's a lot more intuitive than having to program complex code.
I see.
For example, you could send a message to the robot saying, hey, check out that crater over there.
Uh-huh.
And the NLP system would translate that into instructions the robot can understand and execute.
Wow, so it's like we're actually having a conversation with the robot even though it's millions of miles away.
That's the goal. It's about bridging that gap between human intelligence and robotic capabilities.
And NLP is the bridge.
Exactly. It's essential for managing these missions effectively.
Okay, so we've got computer vision giving the robots eyesight. We've got NLP letting us talk to them.
Right.
This is all mind-blowing, but I imagine all this must generate a ton of data.
Oh, yeah, we're talking about massive amounts of data.
So how do they handle all that out in space? Is there some kind of giant space hard drive?
Uh-huh. Not quite. That's where big data and cloud computing come in.
Okay.
We're talking about data from sensors, cameras, instruments. It all needs to be stored, processed, and analyzed.
So it's like having a giant data center in space.
Exactly. And that's where the cloud comes in. Cloud-based systems give us the power and storage we need to handle all that data.
Mm.
And the amazing thing is they can do it remotely.
Remotely.
Yeah, so we can do real-time analysis and decision-making right here on Earth, even though the robot's millions of miles away.
So mission control is getting a live feed of data from the asteroid and can make adjustments on the fly.
You got it. It's like watching a live stream, but instead of video, it's a constant flow of data being analyzed in real time.
That's incredible. It's like all these different technologies, big data, cloud computing, AI, they're all working together to make this happen.
It's a beautiful thing.
It really is amazing to think about all that data just streaming in from millions of miles away and being analyzed right here on Earth. It just blows my mind how far we've come with technology.
It is pretty incredible.
We've talked a lot about all these different tools and techniques, but can we kind of zoom out for a second?
Sure.
How do all these pieces come together to actually make these robots truly autonomous out there in space?
That's a great question.
Yeah.
So one of the key things here is something called decision support systems.
Decision support systems.
Yeah, they're basically AI systems that go beyond just processing data.
Okay.
They can analyze information from all sorts of sources. They can run simulations. They can predict outcomes, all that good stuff.
So they're helping the robot make decisions.
Exactly. Instead of just reacting to what's right in front of it, the robot can plan ahead and make smarter choices.
Oh, that's cool.
It's like having an AI strategist on board, helping the robot figure out the best moves based on things like resource availability, hazards, energy levels, and the overall mission goals.
That makes a lot of sense, especially given how unpredictable space can be.
Right.
So are there other ways AI's helping to boost robot autonomy out there?
Oh, yeah, there are tons.
Like what?
Well, one really exciting area is something called swarm robotics.
Swarm robotics. What is that?
So instead of having just one robot trying to do everything, you have a whole bunch of robots working together as a team.
Kind of like a colony of ants or something.
Exactly. It's all about cooperation. Each robot has its own specialized skills, and they all work together to achieve a common goal.
So that makes the whole system more flexible and resilient, right?
Absolutely. If one robot goes down, the others can pick up the slack.
And they can adapt to changing conditions more easily.
Right on.
It's like having a whole team of mini experts out there collaborating on the mission.
I like that.
It seems like AI isn't just making robots smarter, it's changing the whole way we think about space exploration.
You've hit the nail on the head. And there's another really important aspect we haven't talked about yet.
What's that?
Energy management.
Oh, right. Power is a big deal in space.
Huge. AI plays a big role in making sure the robots use their energy wisely. So it's not just about finding resources, it's about using them as efficiently as possible.
So how does AI help with that?
Well, it can do things like optimize how energy is distributed between different systems.
Okay.
It can prioritize tasks based on how much power is available. It can even control the angle of the solar panels to make sure they're getting as much sunlight as possible.
So it's like a little energy manager keeping everything running smoothly.
Very much.
This is all so fascinating, but before we wrap things up, I do want to touch on something we mentioned earlier. The ethical considerations.
Right.
You know, giving robots so much autonomy in space, it does raise some questions.
Definitely.
Are there any particular concerns that stand out to you as we keep pushing forward with this technology?
Well, one of the big ones is the whole concept of meaningful human control.
Meaningful human control.
Yeah. As these robots get smarter and more capable of making their own decisions,
Oh.
we need to make sure we don't just completely hand over the reins. We need to find that balance between letting AI do its thing and making sure there's still human oversight and accountability.
So it's not just about what robots can do, it's about what we want them to do.
Exactly. And making sure their actions align with our own ethical principles.
That's a really important point. Are there other ethical things we need to be thinking about?
Well, another one is the impact on human workers.
Oh, right.
As AI and automation become more common in mining and other industries, we need to think about what that means for jobs.
Yeah, are we going to see robots taking over all the jobs?
Well, it's not that simple. But we definitely need to be proactive about retraining and reskilling workers who might be affected by these technological changes.
So it's about making sure these advancements benefit everyone, not just the robots.
Exactly. It's a complex issue with a lot of different angles.
It really is. It sounds like AI and asteroid mining isn't just a technological challenge, it's a societal one too.
Absolutely. And it's a conversation we need to be having right now.
Well, this has been an incredible deep dive. I feel like I've learned so much about the potential of AI, not just in space, but here on Earth too.
Me too. It's such a fascinating field.
Any parting words of wisdom for our listeners as we wrap up this cosmic journey?
My main takeaway is that what we're learning about AI in space has the potential to change things in a big way back here on Earth.
Right.
Whether it's finding new ways to mine resources sustainably or developing even more advanced robots and automation systems, these innovations have implications that go far beyond asteroid mining.
It's a good reminder that space exploration isn't just about pushing the boundaries of what we know and what we can do.
Mm,
It's also about finding solutions that can benefit all of humanity.
couldn't have said it better myself.
Well, that concludes our deep dive into AI and asteroid mining.
Hope you enjoyed it.
We sure did.
Yeah.
And remember, the future of space exploration is being shaped right now, and AI is playing a leading role. So keep looking up at the stars. You never know what incredible discoveries await us out there.
To infinity and beyond.
Haha, exactly. Thanks for listening, everyone. I'm